Hello friends and welcome. I hope you have enjoyed the videos that I've posted so far. If you'd like me to continue recording and posting videos, obviously the good thing to do is to subscribe. So do subscribe to our channel so that we can continue producing more and more videos, and hoping, of course, that these videos are going a long way in helping you in your calculus course. Right, in this video, we want to find the domain of the given function. Right, our function is obviously a rational function, but look at the denominator. We see we've got a floor function. This floor function is also known as the greatest integer function. So the way we go about it is to apply the same rules that we've applied before in finding the domain of a rational function. That is, of course, to first of all examine the denominator. So our denominator uh, is a floor function. It must not be equal to 0. In other words, if the floor function is equal to 0, then the function becomes undefined. But if we look at the numerator, we see that there is an additional restriction in the form of the square root. You can see that our 2x plus 3 cannot be negative naturally. But of course, we can then look at the 0. Let's examine the 0. If 2x plus 3 is equal to 0, then we end up with square root of 0, which is 0. So there's no problem. So we can start by saying that 2x plus 3 is positive, including 0. Now, obviously, this is an inequality, so we solve the inequality. The easiest way here is to add negative 3 to both sides. So if we add negative 3 to both sides, then this is what we get. And of course, now we can then divide both sides by 2. So if we divide both sides by 2, then we end up with minus 3 over 2, which is the same as what? Minus 1.5. Now, the denominator cannot be 0, so our floor function cannot be 0. So I'm going to write this like this. So we are saying that this cannot be 0 because it's undefined at that point. So what does this mean? This implies that our 4x squared minus 36 lies between 0 and 1. So 4x squared minus 36 lies between 0 and 1. And notice that here I've deliberately put less than or equal for obvious reasons, if you know how the greatest integer function works, right? So let's simplify this inequality by adding 36 right through. So we get the 36 here, and then we are left with 4x squared after adding 36. And 36 plus 1 gives us 37. And we can divide right through by 4. This gives us a 9 less than or equal to x squared less than 37 over 4. Now, because we got an x squared, we can now apply the square root all the way through. So square root of 9 is 3. So that gives us here the square root of 37 over 4. So that's square root all the way. Okay, so that's where we are now. But if we want to express it in decimals, which would be nice, then this becomes 3.04 to 2 decimal places. So let's review what we've written and what do we mean so far. So we know that the integer function cannot be 0, otherwise the function will be undefined. So in other words, we are saying that our 4x squared minus 36, if it's not 0, that means our x, that is the domain of x, must not include this. The domain of x must not include this interval. So in other words, we are saying x must not be inside the interval 3 to 3.04. That's what essentially what we are saying there. So now we can then determine the final domain with the help of a number line. So here I will have my minus 1.5. Then I can have my 0 here. And then somewhere here, I'll put my 3. And somewhere there, my 3.04. So let's feed this information onto the number line. So we know that x is greater than or equal to minus 1.5. So we get a solid, I can put a solid dot there. And then I will take it all the way through. But then I need to exclude this particular interval 3 up to, so then maybe let me put it on top here, 3 up to 3.04 is excluded. So it means our domain is starting from negative 1.5, gets to 3, and we jump this interval because we're excluding it. We jump that interval, and then we continue thereafter from 3.04 up to positive infinity. So the final domain, we are starting here because of the solid dot. So it's negative 1.5, and we go up to 3. Now, because here we've got a solid dot, so here we need to close it like that. Then we open, and here we've got an open dot, so we close. No, here, and then we are starting from 3.04, and we go all the way to positive infinity. And that is our domain.